Okay, this is exponentials and logarithmic equation part 2. The last part we did three different types of example for exponentials. Example 4, we're going to do this part 2. We're going to solve logarithmic equations, and we're going to look at two different types. So example 4 will be the one of logarithmic equations types. So this one will have only one logarithm. Only one side have logarithms. For look at this one, log 4x plus 3. So this side we have logarithm, but we don't have logarithm on the other side. The other example will have logarithm everywhere, and we're going to go over how we're going to solve those in example 5. So if we have only one logarithm, and especially the standard form, where you have log A, B equals to X. This is the standard form, right? So if you have something like small base, larger base, and solution on the other side. If your problem is look like that standard form, then what we can do is just convert this into the exponential, right? Let's look at how do we change the logarithm into the exponentials, right? So it'll be small base solutions equals to larger base, right? So that's the method we're going to use. So example A, we can convert this logarithm into 4 squared equal x plus 3. And we know how to solve this. This is just a simple linear equation. We know 4 squared is 16 equals to x plus 3. And where your x is going to be, subtracting both sides by 3, so it will be 13. That's simple. So if you have a simple logarithmic equations, then change to exponentials. So just convert into exponentials. And then solve for a variable. So let's try another one, B. So this is the simple logarithm. So if we wanted to change this into the exponential, it will be 3 to the 8 exponents equals to 2t minus 7. And we can solve for t by adding 7 first, and then divide by 2. This is 6,561 plus 7 over 2, which your t is going to be 3,284. What about next one? If you don't have a standard form of simple logarithmic form, then you need to make it simple logarithmic. This one right here, you have a multiplications. See, you have a multiplication first. So first thing you can do is dividing both sides by 4. So I will divide both sides by 4 to get rid of the multiplications to make it standard form of logarithm. Then I will get log or natural logarithm of 3x equal 2. And we know that natural logarithm it is same as log e 3x equal 2. And we can convert this into the exponential. And then you divide both sides by 3. So your x is e squared over 3. Now we're going to look at example 5. What about if you have more than one logarithms, right? You have logarithm on one side and you have logarithm on the other side. There are two different ways of doing this. So I'm going to show you both ways, and you can pick and choose whichever method you wanted to use. Okay. So first one I'm going to show is I'm going to multiply both sides by log 2 so that I can get rid of the logarithm completely. Okay. So I will divide both sides by log 2. That will cancel out this 2, right? Only thing remaining is going to be 3x minus 4 equal x plus 2. Then solve for linear, right? So put the number with the variable together, number without the variable together, give you 2x equals 6, where x is 3, right? And long as this answer will not give you the larger base negative, then it's okay to keep it. That's only restriction we have. So replace 3 here. 3 times 3 is 9, minus 4 is 5. So not negative, so it's okay. Let's try on this one. 3 plus 2 is 5, not the negative. So we should be okay to keep it as x equals to 3. So that's one way of doing it. The second method, I will say, I wanted to put all this into one side, right? So I will put it one side equals to 0. Then this is going to be equals to 0, right? So what I just did was left side logarithm 2 and right side logarithm 2, I put it all together on the left side. So this right side become the negative. I put it all one side, all the logarithm all to the same side, so I can use the property to combine and make a single logarithms. So if I wanted to make a single logarithm, I will get, this is subtractions, so this will change to divisions. And then, once it's a single logarithm and standard shape, then I can change it to exponentials like I did it on example 4. So if I change this to exponential, it will be 2 to the 0 exponents. So from here to here, changing to exponentials. And it gives you 2 to the 0 exponents equals to 3x minus 4 over x plus 2. 2 to the 0 exponent is 1. And then you multiply both sides by x plus 2, then you get this, which is going to be same as the beginning right there. So you can work either way. And look like the first way was shorter, but sometimes you have to put it or combine them to make a single logarithm. Like next example, you see. Because you need to combine it, because if you look at on the left side, you have more than one term, right? So you need to combine this, even in order to use the first method, right? Multiply both sides by logarithm to get rid of the logarithm. Even you wanted to use that, this problem, you have to combine this one into one term first, right? So let's try that. So look like the first method was easier, but this one you do need to go through combining the natural logarithm first. So on the left side, you have only single logarithm. the right side, you want it to make a single natural logarithm. So this is subtraction. So we'll be change it to divisions. Once it's single logarithm, then you can divide both sides by natural logarithm to get rid of log. Then you get x minus 4 equal x plus 6 over x. And then you can get rid of x by multiply both sides by x, so that you get rid of the fractions, right? So then you get x squared minus 4x equal x plus 6. And look like this is quadratic, so you're going to make a standard form of the quadratic by putting all one side equal to 0. Combine the like term. And then factor. This trinomial look like factorable, which is x minus 6 and x plus 1. So you have x equals to positive 6 and negative 1. And before you circle or verify that, both will be your solution, you need to check them, right? So when you're checking 6 minus 4, positive. 6 plus 6, positive. Then 6 is positive. So 6 is okay. What about negative 1? Negative 1 minus 4. This is going to become negative 5, where you cannot have negative larger base. Same thing with this one. Ln negative 1, that's negative on the larger base. So you cannot use negative 1 as the solutions. Only solution you can use is positive 6. Do not just exclude because it's negative numbers, because when you're checking or replace back into where you started, sometimes negative value become a positive, right? So you need to make sure you replace it into the original problems to make sure you don't get negative on the larger base. What about this problem? See, what I like to do is, because here, this problem I have two ways of doing it, where I can put all the logarithm on one side and leave the value on the other side. So let me show you. I'm not going to work on both ways, but I can just show you, start the problem. So I can put the logarithm together. Equals to 3, and combine the logarithm into single logarithm. Once it's single logarithm, then you can change it to exponentials, right? Change it to exponentials. Give you 2 to the cube equal x times x minus 2. And then you can solve from there, right? Or the other way of doing it is make it log on the each side of equations. So 3, I can change that into log 2 to cube, right? I have to use log 2, small base 2. So if I wanted to make this term into 3, then larger base have to be same as the small base, and exponents become your solutions. So this 3 can become log 2 to cube, right? So you change to that into the logarithm, and then you have log 2 x minus 2. And then you can make single logarithm on this side by combining on the right side. That gives you log 2 cubed is 8 times, oh, wait, not times, because it's subtraction, it will be divisions, right? X minus 2. Once you make a single logarithm on each side of equations, then you can divide both sides by log 2 to get rid of the logarithm. And then you will get only x equals to 8 over x minus 2. And when you multiply both sides by x minus 2, you get same thing as the other side. So it's up to you whichever way that you want it to do. You want it to put it all one side and make a single logarithm and change to exponentials. You just put both side logarithm. So if you have a whole number, you need to be able to change to the same logarithm as the other one and combine them using the properties, right? And then get rid of logarithm by dividing both sides by the log. Either way, you get exactly same place. And then when you open the parenthesis, you realize that's quadratic, so then you make it standard form equals to 0. And look like you can factor this. It will be x minus 4 and x plus 2. So your x can be either positive 4, negative 2. Let's make sure if we can keep both solutions by replace back. 4 will be okay, but negative 2, I cannot use it here because then my larger base will be negative, which is one of the restrictions you have for logarithms. Logarithm cannot have larger base negative, right? This one will be the same thing. Negative 2 minus 2 is negative 4. So we need to make sure we exclude negative 2 as the solutions and only keep 4 as the solutions. The last example that I'm going to go over in this section, some people will say, why do we need to learn how to solve exponentials and logarithmic problems? How do we use this in our real life? So the next sections that we're going to look at it is going to be applications. But even before we do the application, I wanted to give you one example here. We deal with the interest formula before, and even with the interest formula questions, we should be able to use the exponentials and logarithms solving equation method. So this is an example I wanted to go over. How long will it take 25,000 to grow into 500? I need one more zero. At 9% annual interest compound monthly. We did one example using compound interest formula before, and I have interest formula right here. So this is the formulas we're going to use. We know that A is amount, P is principal, R is rate, N is going to be compound period, T is going to be times. So if we replace all that with it's given, how long? So basically what we're looking for is the exponentials, right? T, how long it's going to make principal 25,000 into 500,000. So let's replace all those values and see what we're looking at. So A, total amount become 500. Principal, we're starting 25,000. 1 plus, your rate is 9%, 0.09. And N is going to be compound monthly, so we have 12 months a year. And N is going to be 12, and T is unknown, how long. So that's going to be T questions. Trying to find what t is equals to, right? So then, this is what we've been dealing with, solving exponentials, right? Order to solve exponential, first thing you wanted to do is isolate the exponential terms. So you're going to divide both sides of equation by 25,000. So you will get rid of multiplications to the exponential term, right? So then you get 20 on the left side, and you get 1 plus 0.09 over 12. That's going to be 0.0075 to the 12t exponents. So then that is again 1.0075 to the 12t exponents. And we multiply both sides by natural logarithm to bring down the exponents. So bring down the exponent. And then divide both sides by 12 in 1.0075 to isolate only t, right? Then your t is going to be equal to ln 20 over 12 ln 1.0075. And you need to use the parenthesis to plug in those values into the calculator. Then you get close to 33.41 year. So if interest is 9% high, then it takes about 33 years to make 25,000 into 500,000. And we will see more example like this where we're going to use exponentials or logarithm to solve the word problems. And we'll see that in the next sections.